Okay, so we have we're doing problem 155, chapter 1 in university physics. It says in January 2006, astronomers reported the discovery of a planet comparable in size to the Earth orbiting another star and having a mass about 5.5 times the Earth mass. It's believed to consist of a mixture of rock and ice similar to Neptune. The planet has the same density. What's the radius expressed in kilometers? So for part A, we are looking for the radius. So we know that the density is equal to the mass over volume. If we can find the volume, and the volume is a function of the radius, we can go back and find the radius because it's just a sphere, yeah? So we're going to find V now. So we know that V equals m over d. And we know that the mass is 5 times the mass of the Earth, or 5.5. So this is going to be 5.5 times the mass of the Earth. What's the mass of the Earth? Let's look that up. So mass of the Earth, instead of going to the appendix, is 5.972 times 10 to the 24 divided by the density. We have the density to be and so this mass is in kilograms. To change it to grams, we multiply it by another 10 to the third because we have the density in grams. So divided by 1.76 grams per centimeter cube. All this is in grams since we converted. And now the grams crosses out the grams, and we will get the volume in centimeters cube. So if we do this, we get 5.5 times 5.972. So the volume is 1.87 times 10 to the 28 centimeters cube. And we know that since this planet is a sphere, right? It's a sphere. We're gonna, right? It has the volume of a sphere is 4/3 pi r cube. And we know that this is equal to this answer here, 1.87 times 10 to the 28. So now we can cross multiply and find r to be 3 times 1.87 times 10 to the 28 divided by 4 pi. And we can take the cube root of that, or we could just raise it to the 1/3. Either way. And of course, this will give us the answer in centimeters. And the question is asking for the answer in kilometers, then we can convert. So 3 times 1.87 divided by 4 pi. We get this to be 1.65 times 10 to the 9 centimeters. And so now we can convert it. Every 1 kilometer is 10 to the 3rd meters, and every meter is 10 to the 2 centimeters. So this altogether will be 10 to the 5th centimeters. So this will be 1.65 times 10 to the 4th kilometers. So this is the radius of the planet. And for part B, we need to express it as a multiple of the Earth's radius. Yeah? So for part B, the radius, so this was the radius of the planet. Yeah? R for the planet. So the radius of the Earth is equal to, if we go to the Google instead of the appendix, be faster. So radius of the Earth will be 6,371 kilometers. Yeah, so the radius of the planet, yeah, is equal to 1.65 times 10 to the 4 divided by, we need to express it as a function, or how many times it is the radius of the Earth. So this is over the radius of the Earth. So if we divide both of them, 6,371, so we would get the radius of the planet to be this divided by 6,371, we get 2.58 the radius of the Earth. So it's 2.58 times the radius of the Earth happens to be the radius of this planet. This does it for this question. Please don't forget